Think of the coordinate plane as a giant map for geometry. It helps us pinpoint the exact location of any object or corner of a shape. It's built on two lines, or axes, the x-axis running horizontally and the y-axis running vertically. Every point on this map is a street address, written as an ordered pair, x, y, where x is the left-right spot and y is the up-down spot. In earlier grades, you probably focused on quadrant 1, the area where both the x and y values are positive. To plot a point like 3, 5, you start at the center, the origin, and move 3 units to the right along the x-axis, then 5 units up along the y-axis. It's like navigating a neighborhood map, right first, then up. But now, we're opening up the map to include negative numbers. The plane is divided into 4 sections by the axes. If the x value is negative, you move left. If the y value is negative, you move down. For example, the point -2, 4 is in quadrant 2 because you move left 2 and up 4. Learning to navigate all 4 quadrants is key to advanced geometry. Once we can plot points, we can start drawing shapes. A polygon is just any closed figure made up of straight line segments. We use the ordered pairs to represent the vertices or corners of the polygon. By plotting a set of these vertices and connecting them in order, we can draw a triangle, a rectangle, or any other polygon right onto the coordinate plane. Our first main goal is to use these coordinates to figure out the side lengths of the polygons we draw. For rectangles and triangles that are lined up with the grid, the side lengths are just the distance between the coordinates. We don't need a ruler. The coordinates tell us everything we need to know. Let's look at horizontal lines, which run parallel to the x-axis. Since the line is flat, the y-coordinate stays the same. To find the length, you only need to look at the difference between the x-coordinates. For instance, if a side goes from x equals 2 to x equals 7, the length is 7 minus 2, or 5 units. We use the absolute value sign because distance can never be negative, so it's the absolute value of x2 minus x1. Let's apply that rule. If a line segment connects point A, 2, 1, and point B, 7, 1, notice the y value is 1 for both. It's a horizontal line. The length is the difference in the x values. 7 minus 2 equals 5. Even if you subtract in the other order, 2 minus 7 equals -5, the absolute value is still 5. The line is 5 units long. Vertical lines run straight up and down, parallel to the y-axis. Here, the x-coordinate stays the same. To find the length, we look at the difference between the y-coordinates. The formula is the absolute value of y2 minus y1. This works even when we deal with negative numbers in the lower quadrants. Consider a vertical side connecting point C, 4, -3, and point D, 4, 6. The x value is 4 for both. The length is the difference in the y values, the absolute value of 6 minus -3. Remember that subtracting a negative number is the same as adding a positive one. So 6 plus 3 equals 9. The vertical side is 9 units long. What if a line crosses over the x-axis or the y-axis? Imagine a line goes from y equals 3 down to y equals -2. You're measuring the distance from 3 to 0, which is 3 units, and then the distance from 0 to -2, which is 2 units. The total length is 3 plus 2, which is 5. When a line segment crosses an axis, you simply add the absolute values of the coordinates that are changing. Once we find the side lengths, we can easily calculate the area of the polygon. For a rectangle, the formula is straightforward. Area equals length times width. By using the coordinates to find the length and width, We can then multiply them to get the total number of square units inside the shape. Let's find the area of a rectangle with vertices at A 1, 2, B 5, 2, C 5, 6, and D 1, 6. First, find the length horizontal. 5 minus 1 is 4 units. Then, find the width vertical. 6 minus 2 is 4 units. This is a special rectangle where all sides are equal. It's a square. With a length of 4 and a width of 4, the area calculation is simple. 4 times 4 equals 16. So the area is 16 square units. Remember, since area covers a two-dimensional space, the units are always squared, such as centimeters to the power 2. Finding the area of a triangle on the plane follows a similar logic. The formula is area equals half times base times height. The most important thing to remember is that the base and height must always be perpendicular, meaning they form a right angle. For right triangles drawn on the coordinate plane, the sides that run along the grid lines are the perfect base and height. Let's look at a triangle with vertices P 1, 1, Q 7, 1, and R 1, 5. We can see the side PQ is the horizontal base. 7 minus 1 equals 6 units. The side PR is the vertical height. 5 minus 1 equals 4 units. We now have our base and height, 6 and 4. With a base of 6 and a height of 4, we plug these into the triangle area formula. Area equals half times 6 times 4. First, multiply 6 times 4 to get 24. Then, take half of 24. This gives us 12 square units. It's the same basic formula you've used before, just with a coordinate step to find the dimensions. What about polygons that don't have neat horizontal and vertical sides, like a triangle that's tilted or a trapezoid? We use a powerful technique called the box method. You start by drawing the smallest possible rectangle, or box, around the entire polygon. This creates a larger, simpler shape that is easier to measure. The box method works in 3 parts. Step 1. Calculate the area of the large outer rectangle. That's the box. Step 2. You'll notice that the box contains your polygon plus some empty triangles and maybe some small rectangles in the corners. You must calculate the areas of those extra shapes. Step 3. Simply subtract the areas of those extra shapes from the large box area. What's left is the area of your complex polygon. Let's summarize the key points. When you're measuring lengths on the coordinate plane, you're always using subtraction, the absolute value of the change in x for horizontal distance, or the absolute value of the change in y for vertical distance. Remember, distance is always positive. And finally, always rely on the standard area formulas you know. Here's a quick final challenge for you. Draw a shape on your own paper with vertices at 1, -2, 4, -2, 4, -5, and 1, -5. Find the length and the width, and then calculate the area. You should find the length is 3 and the width is 3. That means the area is 9 square units. Great work exploring geometry on the coordinate map.